Cast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to the next installment of our Saratech Enablement Series. My name's Andrea Hall, and I'm the Customer Relationship Manager here at Saratech, and I'll be your host today. Presenting today, we have Kelsey Safar, who is an Applications Engineer here at Saratech, and she'll be teaching some tips and tricks about what's new in ST10. First, I want to tell you a little bit about the Saratech Enablement Series that we've had such great success with. We usually run about 30 to 45 minutes, and our training is always led by subject matter experts. We cover topics including VMAP, NX, Solid Edge, Team Center, and much more. Our goal for the Saratech Enablement Series is to help you get the most out of your software, to share knowledge amongst each other, and to build a community of users that'll help empower each other. As always, this is an open forum, and we look forward to you participating in the training. So if you have any questions or comments during the presentation, please type them in the chat box or in the questions box, and I'll kindly interrupt Kelsey and let her know your comments and questions during the training session. And with that, I'll pass the baton over to Kelsey.
Hi, everyone. For those of you who are just tuning in, my name is Kelsey Safar, and some background information about me. I have been with Saratech for almost a year now. I graduated at University of California, Irvine with a double major in aerospace and mechanical engineering with a minor in material science. But enough about me. Let's talk about Solid Edge. So some things we're going to go over: the Solid Edge portfolio, some trends that we're finding in the industry, and the reason why you guys are tuning in: generative design, additive manufacturing, and reverse engineering. And then I'm going to hand it over to Andrea for some final remarks. So as you guys all know, Solid Edge has just released its newest version, ST10. And Solid Edge is equipped with many features to seamlessly allow engineers to implement their designs really efficiently through design, simulation, manufacturing, and all these shown. But today we're just going to go over design. However, if you do notice something that interests you, go ahead and let Andrea or I know at the end of the webinar, and then we'll contact you afterwards. So some trends that we're seeing, well, fast manufacturing is definitely one of them. If you can see from these statistics, 47% of manufacturers expect material costs to increase up to 5% in the next 12 months, meaning engineers need to figure out ways to use less material, and Solid Edge is equipped with that, with its topology optimization, and its function is generative design. Next is 3D printing. As you guys all should know, 3D printing is not really a wave of the future. It's now here. I just recently went to a manufacturing conference, and half those machines were completely 3D printers. So they're pretty important. 50% of injection molded plastics will be produced with 3D printers by 3D printed molds by the year 2025. And Solid Edge is again equipped with seamless transaction of allowing the engineers and designers to implement their designs in real time with a great feature that with additive manufacturing. And last but not least, we have 3D scanning. So 3D scanning is expected to increase by 10% each year to become a $6 billion business by the year 2025. And so Solid Edge is ready to take on a lot of that 3D bulk data using its reverse engineering feature. So enough about that. Let's go on to our first topic, generative design. So switching over to Solid Edge. If you guys can all see, we have a nice Bernina sewing machine designed by some people here at Siemens. And as you guys know, some sewing machines are expected to become really portable, so switching on to the mainframe. The reason why I say that is because this design was held up by a chassis, this part right here. It's pretty bulky. It's supposed to be steel. Obviously, that's way too much material. It's going to be heavy, especially for a portable sewing machine. So what we can do with Solid Edge is cut down that material cost using generative design. So here at the top the top window. We have Generative Design right here, and we also have it on the left-hand side. So we're just going to pin it right here. Today we're going to go over 2 Generative Design parts. This one already has its own study, but don't worry if you want to go. We're going to be going over another part more in depth, but right now let's just get a little bit more used to the interface. So like I said, this is steel. However, we can either import another material using our materials table, or all the options right here, where we're just going to click steel. Like I said, this one has a generative study already prepared. And then the geometry options. So design space is only if you have multiple bodies within your windows and you want to, exactly what it sounds like, change the different space that you're going to work with. Manufacturing settings are if you have voids or overhangs, and then preserved regions are what the study has. So it's all the holes. So say you want to preserve while doing topology optimization, that's totally fine. You would just click preserve region. I'm going to hide this right here, and just drag and drop whichever hole you would like. So this one we have all these in red. Next, we have the loads. So a few things that I want to go over when doing the loads. You can do it in directions, the different faces or features, but we have this offset here. And the offset is being the depth of the region. So you're going to always need to have a value within that. So if you have a 0 value, then no volume will be created, which is not what you want. You're going to definitely need an offset. And this force also has its own. So right here, like I said, it has its own load as well. And then the next one we have, so there's pressure or torque, but this part doesn't have pressure or torque. It just has regular loads. And the next one is being constrained. So this one's a fixed constraint, but we also have pinned, but we are not having, of course, this sewing machine isn't rotating at all, except for maybe the needle. But for this control arm, it's fixed. And this generate tab, it's basically the study that we're going to do. So the generated tab is dependent on 2 variables. The length of the quality, so the higher the time, the better the quality. And so if you want to have, say for preliminary studies, you might want to only do it at 50%. And then say for your final design, you might want to do it at 300. And then the target mass is pretty nice. So say you didn't know really the percentage you wanted to change, but you knew the target mass, you can just scroll here, and the target mass is shown right there. And then the allowable stress is just dependent on the material that you choose. So we're going to close that one out right here. And like I said, we have our study already prepared. So we're going to show that right here and show the stress. So we can see, I'm going to close this design body. We can see right here that this is what the study created for us. And if you look, the red, if it stressed that much, it would be red. So that's high stress, and purple would be the least amount. And something that I do want to convey with the front showing, Solid Edge will never increase the amount of material that you had set limits for. So zooming into this part right here, it's never going to add more material. It's always going to be within the limits that you previously kept, which is good because you don't want your new design to run into your other parts. So we're finished with that. And so Solid Edge doesn't have its own stress data. It's because the simulation is on a mesh body. So Generative Design will only output color mapping. So if you need more of a stress data, I would suggest to import this part into FEMAP or whatnot. The stress data is, like I said, it only shows the color mapping. So we're gonna close this. And once you feel like this design is good for you, go ahead and detach it from the body or from the study. A lot of people kind of forget that, and that's the only way you can toggle between the construction body and the design body. So let's hide that. So we're going to toggle through. And for some of you guys who might not know, the design body is what's going to be, accept that, it's what's going to be imported in your assembly. So looking right here, our part is nice and clean. And we definitely shaved off a lot of material. But for those of you maybe who are just tuning in, we're going to do another generative design on this little lever right here. So we're going to open that up. And we're going to do a step-by-step analysis. So let's add the base so we know where the forces are going to be. This material is also going to be steel. Create the generative study. And we're not going to need to preserve any regions because we're going to do a topology optimization of the whole part. So we're actually not going to utilize those, but we are going to utilize a force. So it's going to be with this base, but we're going to flip that in. And like I said, you always need an offset. Ours is going to be 2. And you can notice that right when I accepted it, the volume did change. And so we're going to do a fixed pin on this face. Hit accept of 2. All right, perfect. And you could tell by the arrows, that's where your force is going. So sometimes it can get a little tricky when you select things. So make sure that your force is in the right area. And then click generate. So obviously, this being a 30-minute webinar, we're not going to do a high quality study. We're going to do something really quick, probably just 40 seconds. And then we're going to target the mass around, let's see, I think 15, because I like odd numbers and 23 is my favorite number. We're just going to click generate. So as we're letting this generate and optimize, there's going to be a window that pops up at the very end. And essentially what it's saying is that this quality study might not be the most optimal. To make the best study, you're going to want to increase your time and perhaps increase the amount of weight that you choose. And it's going to pop up in 3, 2, 1. There you go. So like I said, the best result was returned, but extra care is during validation. Increasing the study quality and or reducing the mass reduction target may produce a better result, which is pretty obvious. But we'll show the stress. And like I said, it's just the color mapping. But it's really convenient. Say if you wanted a quick design and you need to decrease the amount of weight in your assembly, this is a great way. Maybe you want to do a PowerPoint, send it over to your boss. It looks pretty nice. But we're going to accept it, detach it from the study, and toggle between the design and construction. And just click yes. And going back to assembly, we can see that it's perfect. It looks really nice. And just like that, in a matter of, well, a little bit more than 40 seconds, we decreased our part with, and we made sure that it's, it's still pretty safe. It's relatively safe. But say, like I said, this was a mesh body. Say we wanted to design it and kind of edit it like a B-rep surface. Due to convergent modeling, Solid Edge allows you to do that. So say if we wanted to add a counter bore right there, super simple. Just start designing like how you would a regular part. So we're going to do a counter bore. Move the live section about 6 millimeters. All right, that looks good. And then we're going to do a little offset right here. We're going to add it to this plane. Click yes, project with offset, please. Select this wireframe. We're going to do an outer counter bore. And let's clean this up. Let's take away the live section. And then just like that, using synchronous technology and convergent modeling, we can make a part however we decide. You're pretty much only limited to your imagination. And going back to the part, if we close up, we could do a little close up, we can see the counter bore is right there. So we're going to save that part. Fantastic. All right. So going back to the presentation, so that was generative design. a little bit overview. We optimized our designs to meet specific strength, weight, and material usage goals. We minimized the costs. We used traditional modeling methods to utilize the counterbore design. And last but not least, we create designs that take advantage of new additive manufacturing technology. So we haven't done that yet, but it goes into our next topic, additive manufacturing. So going back to Solid Edge, we're gonna utilize additive manufacturing with the part that we just made with generative design. So seamless transition. So just like how you would a regular paper report, if you wanted to print one out, it's same with 3D printed parts. So on the applications button, just scroll down to 3D print, hit select, hit preview, and our part is right there. So this 3D print button, say if you had one of Microsoft's printers, just like these shown here. So these have USB connections. So if you were to implement it into your computer or import it in your computer, Solid Edge would recognize it. But say you don't have that. Say you have a Mark Forge printer and you need an STL file. All you would need to do is click STL, hit export. Let's say we want to save it towards here, and you would go back here to this is our part that I implemented in Mark Forge. And a lot of 3D printers nowadays are cloud-based, so you're going to need that STL file. So going back here, you could just import it right there. But let's go back to Solid Edge. There are options when uploading an STL file. Here are the options. So you can do convergent tolerance, surface plane angle, the type of units that you want, but we're pretty much fine with this. However, say you don't have your own 3D printer and you really need this part made, you only have X amount of money, you only have X amount, Y amount of days, all you have to do is click the order online button, sign your life away with the privacy statement, let that part load just a bit. So Solid Edge has partnered with Through Your Mind to do a cross-reference of a whole bunch of 3D manufacturing companies to allow you to have a cheap and effective and fast design. So it'll load a little bit as the materials are loading. But see, oh, just like that, there's a whole bunch of options. So I'll hit printability and scale. As you can tell, you can filter your 3D additive manufacturing options with material, the type of characteristics. So if you want an acid resistant or the type of technology, say you're picky about that, or density, as you can see, that there's a lot of options for you. So we originally created our part using steel, so why not we go back to it? So as we can see, steel is pretty suspicious, steel 420SS. But if we click the suspicious, and why is it, that material would be loaded into, and you can look at your model and see, okay, well, if I really want it to be steel, maybe I should check out where I put the counterbore. But say you have some leeway and you can extend that scaling option. You can, Solid Edge in real time will change all these other materials, including steel, and see if your part is printable or not, which it is. So say that's fine. Obviously, you're not going to want to change, maybe you might not want to change the scale of your part. That's fine, but it can do, you can intuitively understand that, okay, well, maybe my part might need more material, so maybe my generative design needs to be a little bit more conservative. So going back to additive manufacturing, say, okay, I accept it. I want to print out that part. Just go ahead and click select. And just like how you would order anything on Amazon or whatnot, it's the same through Solid Edge. So $3,231 of that part, yeah, let's buy it. So we click select, and I'm gonna send this bill to Saratech. But just as simple as that, we can create and manufacture our part, and it even shows the type of shipping costs, and that is relatively pretty simple. And what's pretty nice is that printability and scale. You're going to want to see if your part is printable with the material that you choose. So going back, So that's all that is for additive manufacturing. And I did forget one thing going back to the 3D printing option. We do have an STL file and a 3MF file. So the differences between the two is that the STL file only includes surface geometry of a 3D part. The 3MF file includes more information about a material cost or color or more, but you're probably only going to really need an STL file. Like I said, the Markforged printer uses the STL file, so you're going to be fine with that. So going back, like I said, so just to review, we can use the latest additive manufacturing technologies that outputs parts for the STL and 3MF formats. And the 3D printed parts can either be in-house, you can tap it into a network of additive manufacturing services, you can optimize the material selection, the schedule, the cost, and that's the additive manufacturing with Solid Edge. On to the next one. Oh, actually, go back to our presentation. So the next thing that we're going to talk about is reverse engineering. So we're going to skip a slide right now, and I want to focus your attention to that old sewing machine. It's an old school Bernia sewing machine, a little bit older than the one that Siemens had created. But if you take a look at the control arm, how it's really curved, say if you wanted to create a design that's a little bit more retro, you wanted to take inspiration from that, but there's no CAD model for this old Bernina sewing machine. What you would do is that you would take a 3D scanner, import that STL file within Solid Edge, and work from there. So that is exactly what we're going to do today. We're going to open up one of the STL files that we have. See, and the STL file that we made with the 3D printed part is right there. So we're going to choose Control R, open. Do an isometric part, and it's going to be a little bit zoomed in, but we're gonna fix that. All right, like I said, zoomed in. All right, great. So like I said, this is a mesh model. It's an STL file, but say we wanted to fix it up a little bit. No big deal. With reverse engineering, it's completely possible. So some tips and tricks with reverse engineering, because it can be a little bit tricky. You want to be very conservative with the mesh that you keep. Sorry about that. Let's close that. We're going to zoom into this area and say we want to delete this circle right here. Just go ahead and click delete mesh. But before we do this, I want to convey that you want to be very conservative, like I said, with the mesh that you delete and keep. Because you want to obviously keep the original meshing as the ones that you want to, like I said, keep. But for the ones, like I said, that are curved, you don't want to kind of go between curved and linear, because it can get pretty confusing for Solid Edge to recreate and remesh the parts. So it'll kind of make more sense when we go and extract surfaces. But let's fill up these holes right now. And Solid Edge will recognize both the back and the front. So like I said, it highlights it in green. So this is when I would say you want to be very conservative with what you want to choose, because there are different, right when you delete a mesh, it's pretty much gone. You're going to have to fill it up using these options. So there's tangent, linear, refined, and curvature. So I have a window up here that describes them better with pictures. So linear will just create the meshes, and it, like I said, in a linear fashion, but it's not as clean as how refined could be, because what refined does is that it takes the facets and kind of copies the same sizes as those nearby. So that's pretty much what you're going to want to do if it's part of a flat surface. And there's curvature. So when I said you want to be very careful with what meshes you're deleting, say if we went too far ahead and went closer to the curve side, that's going to be a little difficult to go from linear to curvature. You can probably use the identify regions, but to make it easier on yourself, it's good to do it in certain parts. So we're going to do refined, hit accept. fill up those holes, and hit select. So I like to clean up my design as I go. So we're going to toggle this body into a design body, and we're going to clean up this feature. So now it's going to be completely smooth. And some of you guys might try to recreate this back at the office or back at home. And what I would like to suggest is definitely changing your quick pick options. Try to make it a little bit laggier, because sometimes it's really difficult to access the quick pick. So you can just do that by holding over, pressing right, and there should be a settings right here that you can change. So just like that, we completely deleted a hole. But say we want to create a new part using reverse engineering. For example, this is a clamp-like structure, but I don't have a part to go through it, and I don't know the dimensions. What you can do is that you can use reverse engineering by identifying these regions and creating its own part. So automatic will go through your entire part. You're probably not going to want to do that, because it'll notice and change all the meshing into different colors. But you probably don't need to work with your entire part. For us, we don't have to, so we're going to click manual and click the paintbrush. And so another trick is to get really close to the part that you want to identify, or the meshing that you want to identify, because the further out you go, the bigger the mesh. And I'll explain a little bit later why we don't want to do that. But for right now, let's paint this cylinder. So like I said, I'm getting a little bit too far out. If you notice, I'm not painting the entire cylinder, and that's not needed. Solid Edge will recognize the shape of it fairly well. But this is the reason why I don't want to go too far out, is because the further out you go, the closer it can be to that mesh, and you want to keep them separate. So you want to get pretty close to your part. And we're going to do the other side. Oh, see, like I said, I'm getting a little too crazy with that. So let's go back on that. Let's see. All right, let's do that a little bit one more time. So go a little bit close to the cylinder. And I apologize if you guys are getting dizzy with my cursor movements. And when you do identify cylinders, you want to work from the inside out. When you start to extract the surfaces, and I'll explain soon, but we're going to do the other side next. So get a little bit close. All right, great. Hit accept. And Solid Edge is going to recognize that as new planes. So let's extract those surfaces. And this is what I was saying. You're not going to want to have these meshes connect, because we want them to have their own surfaces. So this one, it has its own. It's going to be a cylinder. It's going to generate. And then the other two are just going to be planar. So as you can tell, it would have gotten pretty complicated if all those meshes were connected, which is why you want to get pretty close to your part and be conservative when you do choose those. So hit accept. And once you feel like you have a good shape of your part, go ahead and click select, and you can hide that design body that we made, and you can start to see our design that's coming into form, or at least the dimensions that we kind of don't really know. So using the modify surfaces, we can extend this edge, accept it, and just push it through this, this plane. Hit finish and do the exact same on the opposite side. Hit finish, and we're almost done. All we need to do is intersect the parts now, and I really like this tool. It's pretty intuitive. I love when tools are you don't have to read the instructions. You kind of pretty much know what you're going to do. You select all the parts, and you delete the ones that you don't want. So I don't want all these extra ones. And just like that, you have a nice construction body. But we're not done yet. You might think that all these surfaces are connected. They're not quite. You have to stitch them up. So remember, don't forget to do that. And you know they're not stitched because on your Pathfinder, it doesn't have construction body. So we don't really need a preview. We know what it's going to look like. And just like when I did that, it added the construction body. So using our favorite feature, toggling, we can now have our own design body that we can start to construct and work along and make our own new part. And without even knowing the dimensions, we've maybe even created a press fit situation for our control art. So with that, that's some generative design. But there is one other option that I would like to show, and I have to pull up a new part for that. Solid Edge has convergent modeling, which allows the user to not only work with mesh models, but with B-rep models at the same time. So we have the control arm that we just used, but we also have this B-rep model. Say we want to use both at the same time. A great way to show that is using the subtract option. So I can click my STL file, or STL part or mesh part, hit select. I can use that B-rep model, hit select, and just like that, if you guys noticed, hit finish, the B-rep model cut into the STL file, STL model or mesh model, as you can tell right here. And due to convergent modeling, that's all possible. And you can do other things. So like I said, with you can utilize your old design models on a mesh model. So say if you wanted to put in that other hole, or if you wanted to add and extrude something, so you would extrude and maybe you wanted to do maybe a part number, that's possible too. But due to time, we're just going to show the difference, how you can work with that B-rep model and the mesh model. So that looks pretty nice. So going back to the PowerPoint, so reverse engineering. We seamlessly use 3D scanned components, prepared mesh data, extracted surfaces to utilize the reverse engineering capabilities. We worked with it natively, and we worked with both B-rep models and mesh models, and they were included in our workflow, and you can utilize technology like so. And with that, I'm going to turn it over back to Andrea.
Thank you. Great job, Kelsey.
Yeah, no worries.
Okay, so wanted to let everyone know we do have some events coming up, some really exciting live events in these areas here that you see: Orlando, West Palm Beach, Huntsville, and Atlanta. We are going to be doing a full day of Solid Edge University. Some benefits of Solid Edge University: increase your Solid Edge product knowledge and see firsthand what's going on with ST10. We had a past online session that was it's been really popular on YouTube, and so I would highly recommend that you go check out our YouTube channel and see everything that there is to see about ST10. So you can check out that session, and then you can watch this one again because we are recording it, and we will be posting it to our YouTube channel, and we'll also be sending it out to you today. But if you want to see everything firsthand and then also get that voucher for a free Solid Edge certification program, which is usually $99, then please try to attend one of these events. And if you're interested in that, then you can email us at info@saratechinc.com or marketing@saratechinc.com. Either one of those work, and just let us know. And then also, in case you're not familiar with everything that Saratech offers, we do offer hands-on training classes for all levels of software users, as well as many engineering services that can really help you out if you're in need of any kind of services. Our next customer enablement series, funny enough, will be Kelsey again, and she's going to be talking about licensing made easy for NX, Solid Edge, and FEMAP. We are doing a session on this because that seems to be a lot of the questions that we get from most of our customers on the support line. And so we just wanted to try and create, a replay or a video of that so that it's easily accessible to all of our customers. And thank you for attending. And if you just stick around for just 30 seconds after we end this webinar, we would really appreciate it if you could fill out a quick survey and let us know how we did today. And of course, follow us on all of our social media sites, especially YouTube. You can find all of our training there on YouTube. So if you subscribe to our channel, you will know exactly when all of those are posted. And thank you, everyone, so much, and have a wonderful day.